Our Capstone project is the removal of PFAS from Ontario drinking water. PFAS are a group of man-made toxic chemicals that are used in many household items including food packaging, waterproof clothing, non-stick cookware, and paints. Unfortunately, there is emerging evidence that many PFAS chemicals can cause long-term health concerns. Furthermore, PFAS do not degrade and remain in our environment, including lakes and rivers. As of 2021, 88% of Canadian drinking water was drawn from lakes and rivers. There are currently no drinking water regulations for PFAS in Ontario. However, there is a recommendation made by Health Canada to limit the concentration of PFAS in drinking water to 30 nanograms per liter. We are being proactive and designing a system that can be added to current water treatment plants in Ontario to filter out the PFAS to the recommended level of 30 nanograms per liter. Our solution is designed to serve as a medium-sized Ontario city such as Kitchener or Barrie with an above-average PFAS concentration in the water. Current Ontario drinking water treatment plants have many steps to ensure safe drinking water. Our proposed system would be added near the end of the process once most of the other contaminants have been removed. The first filtration method we've chosen is reverse osmosis. Reverse osmosis removes PFAS using filter membranes and high pressure. As seen in the table on the left, the major drawback of the reverse osmosis system is that it uses a lot of energy to push the water through the membrane filter. Another drawback is that although the clean filtered water contains almost no PFAS, 20% of the incoming water forms a waste stream with a high concentration of PFAS. How did we solve this problem? The remaining contaminated water will be filtered by an ion exchanger, which works using principles from chemistry. The PFAS particles are more attracted to the resin beads inside the ion exchanger than the water and attach onto the surface of the beads. The PFAS, trapped in the resin, can now be easily disposed of. Ion exchange is more energy efficient than reverse osmosis, but is slightly less effective. This is an overview of our system. The remaining dirty water from the reverse osmosis unit is sent through an ion exchanger and all the clean drinking water is mixed together. This design will generate 1.2 meters cubed, equivalent to 3 bathtubs, of resin waste every 3 years. This hazardous waste can then be disposed off-site. Methods to destroy PFAS are currently being researched, but this is beyond the scope of our project. The impacts of our project are safer drinking water and a cleaner environment. By removing the PFAS from drinking water, it reduces the risk of long-term health effects that can be caused by PFAS. In this design, we must consider the impact of our energy usage and greenhouse gas emissions on the environment. The disposal method must also follow hazardous waste guidelines to ensure that the PFAS that just got removed do not get released back into the environment or affect any nearby communities. Thank you for listening to our presentation.